Stephen Hawking was born on a significant day, January 8, 1942, exactly 300 years after the death of Galileo Galilei. This seemed like a sign of the great scientific mind he would become. Growing up in post-war England, he lived in a family that valued knowledge and curiosity. His parents, both Oxford graduates, filled their home with books. They encouraged their children to ask questions about everything. Stephen and his siblings were taught to think for themselves, to challenge ideas. He was a boy who loved to figure out how things worked. He dismantled clocks, radios. He didn't always put them back together, but he always learned. He and friends built a simple computer using old telephone switchboards and spare parts. It showed both theoretical talent and practical skill. He chased big questions that stretched human knowledge. He wanted to know where the universe came from and where it was going. This intellectual freedom and relentless curiosity was the fertile ground for one of the 20th century's greatest scientific minds, ready to challenge our understanding of everything. When it was time for university, Stephen set his sights on Oxford, his father's alma mater. He chose to study physics and chemistry. At just 17, he found the academic work almost too easy. He later admitted he studied very little during his first year, maybe only an hour a day. Instead, he immersed himself in university social life. He joined the rowing team. He became the coxswain, the one who steers the boat and directs the rowers. The role suited him. It required strategy and thinking, not physical strength. His time at Oxford was an intellectual awakening, though he didn't spend all his time in the library. He was known for sharp wit and a laid-back attitude that sometimes masked deep intellect. He found it in cosmology, the study of the universe as a whole. He graduated from Oxford with honors. He went to Cambridge for his doctorate, a world-renowned center for cosmology. At Cambridge, his focus sharpened. There, he dove into the most profound questions in physics. He joined an environment of the brightest minds. Disappointed not to work with Hoyle, he soon found supervision under Dennis Sciama. He was fascinated by Roger Penrose's work. Penrose proposed new mathematical ideas about black holes and singularities. This became the central focus of his research. His passion for physics was undeniable. This Cambridge period marked his transformation into a pioneering physicist poised to change the world. Just as his academic career was taking off at Cambridge at the age of 21, he began to experience clumsiness. He would trip, fall for no apparent reason. His speech started to become slurred. After a series of tests, doctors delivered a shocking diagnosis. He had amyotrophic lateral sclerosis, ALS, a rare and incurable motor neuron disease. Doctors said it would progressively paralyze his muscles and that he likely had only 2 years to live. It was a brutal blow for a young man with a brilliant mind. The diagnosis plunged him into a deep depression. He saw little point in continuing his research, believing he would not live long enough to finish his PhD. He listened to the music of Wagner and felt profound despair. It was a dark time. However, two things pulled him out of this darkness. First, his relationship with Jane Wilde, a fellow student he had met shortly before his diagnosis. Her unwavering love and support gave him a reason to live and a reason to fight. They married in 1965, a statement of hope against the prognosis. Second, he realized his mind remained sharp. He could still think, reason, and explore the universe within his imagination. He decided if he was going to live, he would make every moment count. This renewed purpose transformed him. The 2-year death sentence turned out to be wrong. The disease progressed far more slowly than expected. His physical limits forced new ways of thinking about physics, a struggle that was the start of his most creative and groundbreaking work. With his spirit reignited, Stephen Hawking delved into the most challenging problems in physics, focusing on the enigmatic objects known as black holes. At the time, black holes were mostly a theoretical curiosity predicted by Einstein's theory of general relativity, but not fully understood. Working with his colleague Roger Penrose, Hawking applied new mathematical techniques, showing a collapsing star would form a singularity, a point of infinite density where the known laws of physics break down completely. This work was revolutionary, establishing Hawking as a leading theoretical physicist. He began to think about combining the laws of general relativity with the laws of quantum mechanics. The two theories seemed incompatible. But by applying quantum principles to the edge of a black hole, its event horizon, Hawking made a startling discovery. He found that black holes were not entirely black. They could leak radiation. This phenomenon, now known as Hawking radiation, suggested that over immense periods, black holes could slowly evaporate and eventually disappear. This idea challenged the long-held belief that nothing, not even light, could escape a black hole's pull. It was a profound insight that connected the three great pillars of modern physics: relativity, quantum mechanics, and thermodynamics. Hawking's work on black holes led him to ponder the ultimate question: the origin of the universe. He applied his ideas about singularities to the Big Bang, proposing that the universe itself could have begun from a singularity. In his no-boundary proposal, he imagined asking what came before the Big Bang was like asking what is north of the North Pole, a meaningless question. The universe might be self-contained without a boundary in time. As Stephen Hawking's body became increasingly limited by ALS, his reliance on technology grew. He could no longer write, and his speech had become so slurred that only those closest to him could understand it. He began communicating by spelling out words, letter by letter, by raising his eyebrows when someone pointed to the correct character on a spelling card. The real breakthrough came in 1985 after a bout of pneumonia required a tracheotomy, which took away his voice completely. A California-based programmer developed the Equalizer, a system that allowed Stephen to select words from a screen using a small handheld clicker. Once he composed a sentence, he could send it to a speech synthesizer. This device gave him a clear, robotic voice that became his trademark. It was a slow process, a few words per minute, but it allowed him to continue his research and collaborate with colleagues. As his physical control diminished, the system was modified to be controlled by a single muscle in his cheek, via an infrared sensor mounted on his glasses. With this system he could not only speak but write books, scientific papers, browse the internet, and give lectures to packed auditoriums. It was a slow process, allowing him to compose only a few words per minute, but it was his lifeline to the world, a testament to human ingenuity and his own patience. This fusion of mind and machine allowed Stephen Hawking to remain one of the most productive and influential scientists of his time. His wheelchair was not just a mobility aid, it was a sophisticated life support and communication system, a mobile command center for his exploration of the cosmos. He embraced this technology not as a sign of weakness but as a tool that empowered him. His synthesized voice became a symbol of triumph over adversity. It was the voice that would bring the wonders of the universe to millions, a testament to human ingenuity and his own incredible patience. While Stephen Hawking was a giant in the world of theoretical physics, he wanted to share his passion for the cosmos with everyone, not just fellow scientists. He believed that the fundamental questions about our existence belong to all of humanity. This desire led him to write A Brief History of Time, From the Big Bang to Black Holes, published in 1988. His goal was ambitious: to explain the most complex ideas in cosmology in a way someone without a scientific background could understand. He famously said he wanted a book that could be sold in airport bookstores. The book was an unprecedented success. It captivated the public's imagination, selling millions of copies and being translated into dozens of languages. It stayed on bestseller lists for years, making Stephen Hawking a household name around the globe. He used simple analogies and characteristic humor to make profound subjects accessible. He invited readers on a journey to the edge of human knowledge. The success revealed a deep public hunger for knowledge about the universe. Following his first book, he wrote several others for a general audience, often co-authoring with Leonard Mlodinow. He even co-wrote science adventure books for children with his daughter Lucy to inspire young minds. Through his books, lectures, and television appearances, Stephen Hawking became the world's most recognizable scientific ambassador. He appeared on popular shows like The Simpsons and Star Trek: The Next Generation, using humor to connect with a wider audience. He tore down the walls between the ivory tower and the public, proving the story of the universe is for everyone. Stephen Hawking's life was a powerful lesson in courage and resilience. He faced a debilitating disease that should have ended his career, yet he refused to be defined by his physical limitations. His determination to continue his work, to keep asking questions and to share his discoveries, inspired millions inside and outside the scientific community. He became a global symbol of what is possible when intellect meets unbreakable will. His life was a testament to his own famous words: "However difficult life may seem, there is always something you can do and succeed at." Beyond his courage, Stephen was known for his wonderful sense of humor. He never took himself too seriously. He enjoyed his celebrity status and used it to bring a human face to science. This playful side made him even more beloved, showing a brilliant scientist could also be relatable and fun. His scientific contributions changed our understanding of the universe. His work on black holes and the origins of the cosmos set the agenda for theoretical physics for decades. He pushed the boundaries of knowledge. His theories continue to be studied, debated, and tested by physicists around the world. He left behind a rich intellectual legacy that will continue to inspire scientific inquiry for generations to come. Stephen Hawking passed away on March 14, 2018. His ashes were interred in Westminster Abbey between the graves of Isaac Newton and Charles Darwin, a fitting resting place for one of history's greatest scientific minds. But his true legacy lives on not just in his equations and theories but in the countless people he inspired to look up at the stars and wonder,